Welcome back to Die Hard American Metal. Today, we're staging a showdown, a real battle royale between the unsung heroes of manufacturing. We are going deep, right inside the stamping press, to find out what really makes American industry so tough. All right, let's just dive right in. When you look at a factory floor, you see these massive stamping presses, right? You might think the most critical part is that giant ram coming down, or maybe some of the complex robotics. But you'd be wrong. The real gladiator in the arena, the part that takes millions of cycles of just incredible punishment, is the foundation everything is built on. And that's this right here, the die set. You gotta think of it as the high-stress skeleton for the entire tool. It's the bedrock. Its job is to hold everything in perfect alignment while forces that are, literally thousands of tons just slam down on it again and again and again. So you can see why the material it's made from isn't just some minor detail. It's a monumental engineering decision that dictates everything: precision, speed, and the life of the machine itself. So let's check out our fight card for this explainer. We're going to start with the reigning champ, the classic cast iron. Then we'll bring in the versatile workhorse, structural steel. After that, we'll size up the lightweight modern challenger, aluminum. And finally, we'll step into the ring for the final verdict. So let's get to it. Ding ding. Let's hear it for our classic champion. First up in the ring, our classic champion, the historical heavyweight. For a long, long time, cast iron was the undisputed king of large-scale die sets, especially in the auto industry. You want to know its greatest strength? Its ability to be cast into really complex shapes, which, let me tell you, saves a massive amount of machining time and money. But hold on, because not all cast iron is created equal. In this corner, we've got two very distinct forms, and it all comes down to something microscopic: the shape of the graphite inside. You've got gray iron with its flake-shaped graphite, that's the vibration killer, and then you've got its tougher cousin, ductile iron, with spherical or ball-shaped graphite. That one's the brawler. So what's gray iron's secret weapon? Well, it's this incredible damping capacity. Those little graphite flakes inside, they act like millions of tiny shock absorbers, just soaking up and dissipating vibrations. How good is it? Well, it can be up to 25 times better at damping than steel. Yeah, you heard me right, 25x. In high-precision work, that's huge. It means less tool chatter, a smoother operation, and a better final part. And this table just lays it all out perfectly. It shows you the trade-offs engineers are constantly making. You got your gray irons over here, the GM 238 and 241. They are all about that incredible damping, but there's a catch. They're brittle. So if you need more toughness, more impact resistance, you've got to move over to the ductile irons like the GM 245 or 338. They bring durability that gets close to steel, but you have to give up some of that amazing damping ability. It's always a trade-off. So here's the bottom line. For those massive tools that need absolute stability and the ability to absorb the relentless shock of heavy stamping, cast iron is, without a doubt, the undisputed champion. But you have to choose your fighter carefully. Are you going to go for the unmatched vibration control of gray iron, or do you need the sheer brute toughness of ductile? All right, entering the ring now is the versatile, affordable backbone of the entire industry. This is the material you're going to find in most standard, off-the-shelf die sets: structural steel. It's the real jack of all trades, and it's popular because, well, it's everywhere, and it's relatively cheap. And just like with cast iron, we've got a classic matchup within the steel family. On one side, you have A36 hot-rolled steel. It's tough, it's cheap, it's easy to weld, it's the industry's economical workhorse. On the other side, you've got 1018 cold-rolled steel. Think of this as the precision alternative. It's cleaner, it's stronger, and it's way, way easier to machine. And you can see the differences clear as day right here. 1018 is way stronger, and it machines like a dream. You get these nice, clean chips instead of that gummy mess you get with A36. But, and this is a big but, look at that last row. Because 1018 is worked cold, it's packed with internal stresses. So if a machinist starts cutting into one side of a plate, they can release that stress and the whole thing can warp like a potato chip. It's a real problem. So the big takeaway for steel is that it's the absolute go-to for most standard catalog die sets. The choice is pretty simple, really. You go with A36 if keeping costs down is your #1 priority. You pick 1018 if you need that precision and better machinability from the get-go. But its biggest weakness? Vibration damping. It has basically none. Hit it with a hammer and it rings like a bell. And now, for our final contender, the lightweight, high-speed champion that is seriously changing the game in modern stamping. We're talking about aluminum. But let me stop you right there. This is not the stuff your soda cans are made of. Not even close. No, sir. We're talking about high-performance aerospace-grade alloys. The star of the show is an alloy called 7075T6. It's got zinc in it, and it delivers a tensile strength that is right up there with mild steel. But here's the kicker. It does it at only 1/3 of the weight. That incredible strength-to-weight ratio is exactly what makes it a true contender in this fight. But every champion has a weakness, a glass jaw, right? For aluminum, this is it. Modulus of elasticity. It's just a fancy engineering term for stiffness, and aluminum is only about 1/3 as stiff as steel. So what does that mean in the real world? It means if you take a plate of aluminum and a plate of steel of the exact same thickness, the aluminum one is going to bend and deflect 3 times more under the same force. That is a major engineering challenge you have to design around. However, it comes back and delivers an absolute knockout blow when it comes to managing heat. High-speed stamping generates a ton of heat, and that heat is the enemy of precision. Well, aluminum's thermal conductivity is almost 3 times higher than steel's. It acts like a giant heat sink, pulling that damaging heat away from the tooling and getting rid of it way, way faster. That keeps the whole process stable and makes the tool last longer. So with aluminum, the trade-off is crystal clear. That massive weight reduction means you can run your press 20, maybe even 35% faster, and you put a lot less wear and tear on the machine itself. But you absolutely have to engineer around its flexibility, usually by making the die set thicker. And you have to account for the fact that it grows twice as much as steel when it heats up. So who wins the battle of the metals? After seeing all three go head-to-head, what's the final verdict? Well, the truth is there's no single winner. The best material is a strategic choice. It depends entirely on the job. There really is a champion for every fight. So how does this actually play out in the real world? Well, here are the guidelines engineers use. Let's say you're doing high-speed, high-precision work, maybe stamping tiny electronic connectors. You're going to choose aluminum for its incredible heat dissipation or gray cast iron for its vibration damping. Now, what if you're forming heavy-gauge, thick steel? You need the raw toughness of ductile iron or an even stronger alloy steel. And for a simple one-off prototype tool where cost is everything, easy. You go with the cheapest option, A36 steel. You know, this quote just says it all, doesn't it? Choosing the right material isn't just about picking the strongest one or the cheapest one. It's a sophisticated balancing act. You have to understand the metal itself, the engineering demands of the part, and the real-world economics of production. It's where science truly meets strategy, right there on the factory floor. And that leaves us with a final thought to chew on. As American manufacturing keeps evolving, think about things like gigacastings for electric vehicles. You've got these massive aluminum parts being made in massive cast iron dies. The roles of these materials are constantly shifting and changing. This battle of the metals is far from over. In fact, the next round is just getting started.